The digital circuits we looked at so far, such as your adders, subtractors, multipliers, encoders, decoders, multiplexer, demultiplexer, code converter, all of them were combinational circuits. So we provide one or more inputs to the circuit performs some computation on those inputs, and it produces one or more outputs accordingly. So for example, if you take your half adder, we provide two inputs, x and y for instance, and then it computes the sum and carry as x plus y and x XOR y respectively, if I am not mistaken, and then those are the outputs. So in these circuits, the output only depends on the input you provide. This input, this is the output. So there is no dependence on what the previous set of inputs were. Whereas in sequential circuits, there is memory, meaning the previous state or the previous set of inputs also plays a role in determining what the next output will be. So as opposed to combinational circuits where we just have input and output, in a sequential circuit we have input, present state of the circuit, output and next state. So the state is also binary information. It is again a string of zeros and ones usually, and it is sort of the memory element of the circuit. So the next state which your sequential circuit will go to, as well as the output it will provide, both are dependent on the input as well as the current state. So for the same input, let's say I have one input x and I have one output y. Now for the same input x, if my current state is a 0 0 0, my output y will be different. If my current state is a 1 1 1, my output y will be different. Similarly, for the same input x, and if my current state is a 0 0 0, the next state will be something else, let's say 0 0 1. And if my current state was a 1 1 1, then the next state could be different. This is just an example. The point I am trying to drive home is, in a sequential circuit, the state is what is being remembered, or it is what acts as a memory, and the output as well as the next state depend both on the input given as well as the current state. So this is a very simple diagrammatic representation. You have an input, the logic part of it is the same, it's a combinational circuit and it gives you an output, but some additional information called the state information is also produced by the combinational circuit, that is stored in the memory element and fed back into the circuit. So this is the input and this is the current state which goes back into the circuit. Both determine the output as well as the next state. Moving on, the storage or memory element can store binary information that defines the state of the circuit. So that is what I was saying. State is also going to be a combination of binary values. For example, from 0 0 0 to 1 1 1 if it's a 3-bit value. If it's 4-bit, from 0 0 0 0 to 1 1 1 1, you have 16 available states and so on. So state is also going to be binary values only. So in that sense, it is not some specially encoded characters or anything. It is similar to your input, but the difference being the input, it is just you give the input and it helps in the computation of the output and the next state. That's all. It is not stored anywhere. The state, however, is stored and used in the computation of the output and the next state. So the state gets stored, the input does not. The input and output do not get stored. Yeah, so the sequential circuit receives external inputs which together with the present state determine the output. The next stage is also a function of the external inputs and the present state. This is what we just saw. So within sequential circuits you have two types, synchronous and asynchronous. So before we look at synchronous and asynchronous, we need to remember that every sequential circuit has something called a clock. So this is one more distinguishing factor between combinational and sequential circuits. So if you ask me to broadly differentiate between combinational and sequential, there are 2 points I would give. One, combinational does not have a memory element or something that stores the state information. Sequential has that. And two, combinational there is no timer or clock. Sequential there is. So those are the broad differences. So what is the purpose of this clock? It keeps generating signals or pulses at regular intervals, and this state transition happens in tandem with the clock pulses. So there are different ways in which that can be timed, for example. And okay, before we go into that, I'll give you a quick look at how the clock, so this is what the clock pulse generation looks like. So these lower lines are zeros, the upper lines are 1. So clock is also going to work in terms of binary values. So it's either a 0, 1, 0 or a 1, 0, 1, 0, 1. That is how it keeps going. So this is the period where the clock is 0. It rises to 1. Here it is 1, and it's coming down to a 0, and again it's 0 for a while. The vertical edges are the transition moments when it's transitioning from a 0 to a 1 or vice versa. The horizontal edges, the lower ones are zeros and the upper ones are 1, 0 and 1, or low and high respectively. So now what do I mean when I say the state transition happens in tandem with the clock pulses? Every time the clock moves from a 0 to a 1, the next state can be triggered. Or every time the clock comes back from a 1 to a 0, the change to the next state will be triggered. Or while the clock is at 0 and before it moves to 1, the change can be triggered, or while it is at 1. So you choose one of these 4 positions, either at 0 or 0 to 1, at 1, 1 to 0. So one of these 4 is chosen, and every time the clock is in that position, the state transition happens. So let us say we are using a circuit element which will trigger a state transition every time the clock is at 1. So this is what it look like. Every time the clock reaches the signal 1, the circuit will move from its current state to the next state, and the output corresponding to the newly given input will be produced. Similarly, whenever the clock is at 0, or whenever it is transitioning, it is in the process of transitioning from 0 to 1 or from 1 to 0. So in any case, the state transitions are periodic and the time period is decided by the clock pulses in a synchronous circuit. An asynchronous circuit is one where this clock signal pulses do not happen. Something else triggers the state transition. For example, you have multiple circuit elements or gates connected together, and the first one, let's say, is connected to a clock. So every time the clock pulse is generated, the state transition happens in the first one. So the first circuit element or first gate is now connected to the second gate. So every time a state transition in the first gate happens, that triggers a state transition in the second gate. Every time a state transition in the second happens, that triggers the same in the third, and so on. So that would be like a domino effect sort of thing. So everyone is not connected to the same clock, and something else is triggering the state transition in the second and subsequent circuit element. So that is an example of asynchronous circuits. Now, so storage elements. So we've been talking about storage, right? We said there is some element in your sequential circuits which is able to store state information. So those are the storage elements naturally, and there are 2 main types of storage elements: latches and flip-flops. What do these do? Their function is the same. They store the current state, the information about the current state, and again they provide it when the computation of the next state or the output is happening. Once the next state has been computed, that becomes the current state. So that state information is stored either in a latch or a flip-flop. What is the difference between them? Latches are level sensitive devices, flip-flops are edge sensitive devices. What does this mean? So coming back to our clock timing diagram, this and this, so being at a 1 or being at a 0 is called a level, and transitioning from 0 to 1 or 1 to 0 is an edge. That is the terminology. So a latch is a level sensitive device, meaning whenever the clock is at a level, the state transition happens, meaning either every time the clock reaches a 1, every time the clock is at 1, the current state to next state transition happens, or every time the clock is at 0, it would happen. You need to note that both at 0 and at 1 will not happen in the same latch. So it will either be a positive level triggered one or a negative level triggered one, as you can see here. So positive level triggered latch is one where every time the clock is at 1, the state transition happens. Negative level triggered latch is one where every time the clock is at 0, the transition would happen. On the contrary, flip-flops are edge sensitive devices, edge meaning the transition from 0 to 1 or vice versa. So by the same analogy, we have positive edge triggered, meaning when the clock is moving from a 0 to 1, the state transition happens in a positive edge triggered flip-flop, and when it is moving from 1 to 0, the state transition happens in a negative edge triggered flip-flop. So those are the basic storage elements.